Hey guys, in this video we will be discussing something called the derivative or the rate of change. We will look at the average rate of change and then the instantaneous rate of change. So this video is the beginning of an important concept in calculus. I want to begin with an example. Imagine it's 12 o'clock and you're getting ready to go on a trip from New York City to Boston, which is the green point right here, okay? And it takes you 6 hours to arrive at your destination. So you got out at 12 p.m. right on the road, and you arrived at 6 p.m. And you know that the miles between where you started and where you ended was 300 miles, okay? Now you might have stopped for gasoline, you probably stopped to pick up some snacks and so on, but it took you 6 hours to reach your destination. So what was your average rate of change? Okay, so what was basically your miles per hour? Well, okay, so I have to go back and say something really important about units. Miles, and let's say this was hours, everything that you do from now on, you should really watch what the units are, okay? So you started at 00. That means 12 o'clock. Okay, so this is going to be time. This is going to be your miles per hour. So you started basically at 12 o'clock and at 0. You ended at 6 o'clock and 300. Okay, so with that being said, I want to know your average rate of change. I want to know basically your slope from here to here. Okay, so let's see what that's going to be. I'm going to say change in y, which is going to be 300 minus 0 over 6 minus 0. You got 50 over 1, basically. And that's going to be miles per, you see how I did that? Per hour. So you were driving basically 50 miles every hour on average. Now you might have done 30 to get out of your town, and then once you hit the freeway or the highway or whatever, you probably did 60, then maybe 70, and then back down to 50, and then 40, and so on. Then you stopped for a little bit, then you went back and got on the road and you did 70 again, and then 65, and so on. But your average was 50 miles per hour. Okay, so I hope you guys understand that. So basically, all right now we're doing is taking a look at the slope, okay? So continuing with the same idea, it doesn't matter where you start and where you end. If you want the average rate of change, then you want the slope of the secant line. So you want the slope from here to here, and that's the slope of the secant line, because slope of the secant line means that you're using 2 points, okay? So I can call him x, and I put him into this function, and his y value would be f of x. I can call him x plus a little bit more. So if this is x, this is x plus some little value h. And then obviously that has a y value of f of x plus h. So how do we find the slope of the secant line? Well, you have to line them up as a point. Your first point was x, f of x. Your second point was x plus h, f of x plus h. To find the slope of the secant line, then what you're going to do is just use your basic slope formula that you learned in 9th grade or 10th grade. I always line them up on top of each other. I do this guy minus this guy minus this guy. What do you guys notice? F of x plus h minus f of x over x plus h minus x. You notice that the two x's can cancel out, right? So the slope of the secant line, which is sometimes denoted in calculus books, just the way I just wrote it, is going to be this guy right here. And this is what we call the average rate of change. Now, in the beginning of the video, when I was talking about New York City and Boston and traveling, I was able to tell you the average rate of change the car was traveling, but I was able to tell you between 0 and 6 hours of traveling, right? Between 12 o'clock and 6 o'clock. You might want to know how fast the car was traveling at 1:30 or 2:15 or 3:45. You're not allowed or you're not able to do that with just the slope of the secant line. What you need to do is take this slope of the secant line, right, which reduces here to this guy here. We're going to apply the limit as h approaches 0, okay? And what's going to happen there is you are going to find the instantaneous rate of change. You are going to be able to see how fast the car was traveling at 1:15 or 2:30 or 3:45 and so on. So you have to apply the limit as h approaches 0. Now this is called the derivative or the instantaneous rate of change. So let's say that we wanted to find out what happened at this spot right now, okay? This spot right here. So what would happen here is I need to get this h to approach 0. Think about this. If h became 0, what would be left here? Wouldn't it be just x, right? But we know that limit is not where you actually apply the 0. What you're doing is you are approaching 0. So as this gets smaller, as this h gets smaller and smaller in value, guess what's happening? It's approaching the x. And basically, let's say this guy was the x. Then what we're doing is we're getting this guy to become closer and closer to him. Now, when that happens, you're going to be looking for something called the slope of the tangent line, okay? Which means that it's only going to hit exactly once. Now, these 2 points, x and x plus h, don't really touch each other, but they're like very, very close. I mean, so close that you couldn't even tell that they're not on top of each other. So let's say we had somebody here. You have to use the slope of the tangent line. If we had someone here, we have to use the slope of the tangent line if you want to find the instantaneous rate of change. So the slope of the secant line, I believe that's here, is without applying the limit as h approaches 0. This is the average rate of change. The slope of the tangent line, okay, so if you say the slope of tan, all right, that's the limit as h approaches 0 of f of x plus h minus f of x over h. That's also called f prime of x, which is the derivative. Okay, so now in our next video, we'll be looking at examples on how to do this. But that's basically the concept. Oh, and one last thing. This is called the definition of a derivative. So when questions ask what is the definition of use the definition of a derivative to find the derivative, then they're asking you to use this here.